Okay, so if you have a triangular matrix, upper or lower, you pick the row with the most zeros or pick the column with the most zeros. You're going to have one of each, right? So I'm going to do it with the third row, but I could have done it with the first column just as easily, okay? And you can see how that will work out. So it's going to be 7 times this minor, right? Well, times this cofactor, the cofactor you get from this minor. The cofactor being then -1 to the what? What's I and j for this element? Well, it's third row, third column. I and j are both 3, right? So it's -1 to the 3 plus 3, okay, times the determinant of the minor, 3, 2, 0, 1. Okay? Now, 3, 2, 0, 1 is triangular. And in this case, all that means is you just multiply 3 by 1 and you get the determinant, right?
Right.
Because 2 times 0 is going to give you 0. Okay? So the determinant is 21. Okay? Now I'm not actually going to do it, but if I expanded it on the first column, well, it'd be 3 times -1 to the 1 plus 1. That's in the 1, 1 position, right? First row, first column, 1, 1. So it'd be -1 to the 1 plus 1, which is -1 squared, which is 1. It's going to be 3 times the determinant of this minor, right? What's the determinant of this minor? Well, again, it has a 0 here, so you just multiply the 1 by the 7. Okay? Either way you do it, you're multiplying what? 3 by 1 by 7. So for an upper triangular matrix, if you think about it a little bit, it's just the product of the diagonals. Okay? So in some of the problems I was looking at, I think in a later section, it said, you know, had bigger matrices, okay? If you want to find the determinant, all you really need to do is reduce the thing to upper triangular form or lower triangular, okay?
Does it work the same way with lower triangular?
Well, you can think about it. What would happen if it was a lower triangular? You know, just switch everything. Well, what you would get, you get the transpose, and we've already established that the determinant of the matrix and the determinant of the transpose are equal. We haven't proven it, and we might, and you might even end up being responsible for it at some point, okay? But right now, we just know that the determinant of the matrix and the determinant of the transpose are equal, okay?
Okay.
And that would imply then that the determinant of the lower triangular is what we say. Okay. Again, and you could transpose this and convince yourself. Wouldn't be a bad idea.